Welcome everyone. Good evening. How are you all? I think almost everyone attended yesterday's session. So this is the continuation. As I told you yesterday, today's class is mathematics, permutation and combination. Then tomorrow, that what we are learning today will help you tomorrow to understand different ragas. So today's class is pure mathematics, permutation, combination. So today, if you attend properly and understand that combinations, tomorrow you will create ragas. Not the new creation, what already there in the ragas, 72 Melakarta ragas and Janya ragas. So tomorrow you are going to make ragas. And you can sing also tomorrow. Okay, Justin sir, we can start.
Good evening to all. Good evening to all. Today I will play the rag Kalyani. Kalyani, actually the similar mode is there in Western music also. It's called Lydian. And I will play one Janya raga of Kalyani also. It's also popular. It's Amrita Varshini. It's only 5 notes. It's called pentatonic scale. That also I will play. Audio is clear, I hope. It's Amrita Varshini. Thank you.
This is the second class for this math of Sarigama. Here you can see a tagline here, brain has enormous capacity. At any stage of your life, the brain muscles will grow.
Anyone can be smarter.
Yes, that means you can learn maths at any time. Everyone can learn maths. Okay, now look at this one. Here I have given a question. You can try to find the answer. I wrote something below that. Don't worry about the answer. Teachers are asking questions. Your brain is working. You have to think whether the answer is correct or wrong. Give more work to your brain. So the brain start working and it will grow. Here you can see 4 conditions and try to answer. Yes, everyone got a correct answer. Navneet, Catherine, and Shivam. Before that, Munawir. Everyone got a correct answer. And Catherine, can you explain how did you reach in the answer? The answer is, first you tell me what is your answer.
164.
Okay.
I figure out the 6th number because the first condition was it was well placed and the common number in the first and the third set was 6. So I thought it was 6 and the 2 numbers are correct but wrongly placed. I thought it was 1 and 4 because One, I was sure about the first column. I don't know why, but I don't know. I thought about 167, and also I thought about 164. I'm not sure about the both two numbers on the edge.
Okay. Listen, why did you delete 7? Because in the second column, 387, nothing is correct. So deletion in multiple choice questions, you must have seen that easily you can delete some options and reach in the correct answer sometimes. Okay. So 387 you deleted. So it is not 3, it is not 8, it is not 7. So you can't take 7. That is why you deleted. So the correct answer you got, it is 164. Okay. So whether you got answer or your answer is wrong, doesn't matter. You have to think and find out answer for the next questions also. Now you can see here, with Geor and a house, you have to paint the house. There are 7 colors. Okay. And one condition is given here. One condition, both the windows are same color. And you can either you can write the answer or you can unmute and say the answer.
Ma'am, I have a doubt.
Okay. What is your doubt?
If the house is having all the same colors, if violet is in, can we paint like violet in every window, doors, rooftop, everything?
That both windows only same color.
Yeah, other are different.
Both windows are same color, other colors are different. It is with Geor. Okay. There are 7 colors. You can give all 7 colors here in one place. But when you come to the next place, you can't take the color we used in one place. Okay. The first answer you can see here. The first answer, all the students, those who wrote answer, it is correct. It is 2520. You can use 7 colors here, then 6, then 5, 4, 3. Okay. Now you can answer for the second one. In the second one, doors and door and windows use the same color. I want to see more answers. Children, don't worry about your wrong answers. Yes, Navneet. You try. That is what I told you. No, you have to try. Yes, everyone got correct. Yes, Anna. Yes, Anna, Mary, Ananya, Shivam, everyone got a correct answer. It is 840. It is 840. Here, door and windows are using same color. That is why 7 into 6 into 5 into 4. Now, you can watch the next one. In this case, how many different ways you can paint the house? How many different ways? You can notice here, there is a small change from the previous picture. How many different ways? If both windows are same color. Yes, many of you got answer. Catherine, why it is, can you explain your answer?
Yeah, the both windows are having one color, so I'm taking it part 1 like that. And second part is door, and third part is the walls, and the fourth part is the rooftop. And so obviously 7 into 6 into 5 into 4.
7 into 6 into 5 into 4. Why it is not 7? Catherine?
Yes, sorry. Because the one color was used on the...
You have taken 4. You have taken 4 different ways. That was correct. But
it is already used. 7 is red,
yes,
so it is already
very
used.
good.
Yeah,
Yes.
sorry.
It's already used. One color already used, so we have only 6 colors. Now, you can see the next question. If both the windows and doors are of same color. Now, you can easily write the answer. Yes. Now, 7 into 6 into 5 into 4. 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 7 into 6 into Everyone got a correct answer. Anyone unmute and say the method how you got it? Anyone?
I took windows and door as one part,
Okay.
and the down portion of the house as one part, and the roof as one part. As 7 is already used as red, I have not taken 7. I took 6, 5, and 4. 6 into 5 into 4 is equal to 120.
So you can see your answer is correct. Who was that? Can you tell your name?
Shweta.
Shweta. Okay, Shweta, correct. And everyone got a correct answer. That was a very easy question also. Okay. Now, the next one. A number lock on a suitcase has 3 wheels, each labeled with 10 digits from 0 to 9. If the opening of the lock is a particular sequence of 3 digits, how many such sequences will be possible? No conditions are given. So you can take any number of times. No, nothing is mentioned in the question. Okay, it is a number lock. It is a number lock, no conditions. Catherine, you can think once again. There are 10 digits. Previous question, there are 7 colors. And you have to fill 5 places or 4 places. Here, you have 10 different digits and you have to fill in 3 different places. 3 different places. There are 10 digits. Yes, Catherine.
Hello.
Yes.
30.
I can't hear you.
30.
How did you get to 30?
In each
You multiplied 10 plus 10 plus 10.
yeah, in each here lock opening, it can possible by 10 digits like 0 to 9.
Okay.
Then 0 to 9 and 0 to 9. So
Okay. So every time 10 times, no?
yeah.
Okay. So how many ways you can?
So 10 into 3, 30 ways.
3 places. The first place you can fill by 10 digits. Next place also 10 digits. Next also 10 digits. Yes?
Yeah.
Yes, Dibesh, your answer is correct. Many people got a correct answer. So here 10 digits, next place 10 digits, next place 10 digits. So it will be how many times? The previous question, you can think about the previous question. 7 colors simultaneously with the 6 colors. Then with the 5 colors. The same way here, the first place is filled by 10 digits. Then 10 digits, then 10 digits. Then what will be the answer? The answer is 10 into 10 into 10. So you can create 1,000 numbers on the lock. Okay, yes, Catherine. Okay, did you understand?
Yes, ma'am.
Next one. The same lock, but the condition is different. Opening of the lock is particular sequence of 3 digits, but no repeats. That means if you use a digit, you can't use that digit in second time. Yes, Krida, Nikita, Navneet.
Can I say?
Yes,
Is it 10 into 9 into 8?
10 into 9 into 8. Yes, your answer is correct. It is 10 into 9 into 8. Why it is 10 into 9 into 8?
Because here the first lock has 10, that the number cannot be used in the second. So it
Yes.
would be 9 digits, then 8.
Yes, correct. Vedashree, can you? Okay. Can you explain how you got your answer?
Ma'am, I was about to put 720. I don't know how I got 504. I got two answers.
Okay,
I
okay. No problem.
corrected my mistake.
Okay, okay. So your method was correct, only the calculation error. Okay. Now, we will move on to the next one. Can you read the question?
Yes.
How many two-digit numbers can we form using these 9 digits if repetition is allowed?
$729.
You got a 729. It is two-digit numbers, okay? Two-digit numbers. Priya,
81.
who is that?
Shweta.
Shweta. Okay, Shweta. Explain. How did you get the answer?
Two-digit numbers the same way as you said in that log case. I just applied it here. 9 into 9, 81.
Yes, 9 into 9 you applied. Your answer is correct. 9 into 9, 81. But you can see another question here. Now try the answer for the next question.
72.
72.
72.
Are you sure?
Yeah.
Yes.
Yeah.
Okay. So your answer is 9 into 8. We can't use the first digit, whichever you used in the first place, you can't use it again. So it will be 9 into 8. Okay. Now those who did not try for the previous question, you have to try for the next question. Okay. Try. If your answer is wrong, doesn't matter. Take time and read.
Hundred.
100.
I'm giving time to everyone. Okay. I'm waiting for everyone. Let the answers come. Then I will show you the answer.
Hello.
Yes.
81.
Your answer.
Tarun.
Tarun. Okay. Tarun is saying 81. Many students are saying it is 100. Now, Tarun, how did you get 81?
So in the same when we use 0 then 1, we can't use it as a double digit number. No, it is only 1. 0 and 1. The value is just 1, so we can't take 0 to this number. So the just 9 digits. So 9 into 9, 81.
Okay. Now, can you see here the answer? I used 9 into 10. Do you know why?
Yeah, because I did not notice the condition if repetitions allowed.
Repetitions are allowed. Many students wrote 10 into 10. Why it is not 10 into 10?
Because 0, 1, 0, 2,
The
0,
first 10. So 0,
Yes.
1, 0, 2, that.
10th place 0. If you keep 0, then it will be a one digit number. Okay. So you can't keep 0 in the 10th place. Okay. So you can keep only 9 digits in the first place. Then the unit place you can keep all the digits. So this shows that you are giving arrangements in different ways. You are arranging the numbers. When you arrange the digits, you have to think about properly the conditions. Each and every time the condition is changing. Here 0 included, and I am asking about a 2-digit number. And almost everyone give the answer 100. So conditions are more important when you go to Ragas level. Okay. So the way we are arranging the digits, there we will arrange the swaras. but conditions are more important. Now, next question. You can try the next question. How many 2-digit numbers can we form using these 10 digits if repetitions are not allowed? If repetitions are not allowed, how many different ways? Yes.
90.
Different answers are coming. Let everyone write. After that, I will show the answer.
I think it's oh my god, 80.
80. You can
I
calculate.
think it would be 81.
81, 72, 81, 90. Different answers I can see here. Okay. Anyone can explain? Nikita.
Yes, ma'am. So since the repetition is not allowed and here 0 cannot be used in the 10th place, first place there are only 9 possibilities, and in the second place we cannot use we can use 0 and 8 other numbers, so it's 9, so 9 9s are 81.
9 9s are 81. Okay. So look at this one. 10th place we can keep 9 digits. Once we use the 1 digit in the 10th place, we are not allowed to use in the unit place. So in the unit place also we can use 9 digits. So altogether it is 9 into 9, 81. Do you have any doubts up to this? If you have any doubts, you have to tell me. Then I will explain and we will move on to the next one. No doubts. Tarun
No
says
doubts.
no doubts.
No doubt, ma'am.
No doubt. Is it clear? It's clear. Okay. And you can see that different types of arrangements in each and every time. You are just multiplying. Now look at the next question. Now it is 3-digit number.
1000.
It's 1,000.
Okay. It is 3-digit number. We have 10 digits, but it is a 3-digit number. Okay. 3 digits.
Oh, sorry. It's wait, no.
Okay. Try. No issues. You can try.
I think I got 980.
You got
999.
999. How many 3-digit numbers are there altogether?
900.
I guess it would be 900.
900.
Why are you guessing? Here we have a certain rule, no?
It
The
is
previous
900.
questions, how did you follow? The same way you can follow.
It'd be 900.
Yeah.
900.
900 for sure.
900
Yeah,
for sure.
900. Yeah.
Okay.
That's
Someone told 999 3-digit letters numbers are there. 3-digit numbers are starting from 100, not from 1. Okay. 3-digit numbers are starting from 100. Yes. Okay. Now you can see the answer here. It is 9 into 10 into 10, 900. So the correct answer is 900. Those who got 999, that is 1000 minus 1. But you can see here 1 to 99 is 2-digit numbers. Okay, so try with these multiplication, fundamental principle of multiplication, you will get answer without error. Now try the next one. It's a 4-digit number formed using this 10 digits. 4-digit number, repetition is not allowed. There are 10 digits. Okay, first place, that is from the left side, the first place, you can keep only 9 digits. That is correct. But what about the second place? Yes, Dibesh. What about the second place? Second place, you can keep 0 also.
And
You
that will
can't.
also be 9 digits, no?
Yes, 9 digits, correct. So how will be the answer? The answer will be 9 into 9 into 8 into 7. And many students got that answer. It is 4,536.
Ma'am, can you explain how you got that answer?
Okay. This is a 4-digit number, right? And
Yes.
we have 10 digits in hand. So unit, 10, 100, 1000 place. So in the 1000 place, we can keep only 9 digits. That you know. 0 we can't keep. If you keep 0, it will be a 3-digit number. So in that 1000 place, we can keep 9 digits. Now, when you move on to the 100th place, in 100th place, one number you can reduce, but we can keep 0 in the 100th place. So total in the 100th place also, you can fix 9 digits. Is it clear?
Yes.
After that, when we move on to the 10th place, already 2 places are occupied with the 2 digits. So we can't use that 2 digits again. So 10 minus 2, we have only 8 digits. So we keep 8 digits in the 3rd place, that is 10th place, then 7 digits in the unit place. So it will be 9 into 8 into 7, that is 4,536. Okay.
Yes, thank you.
Is it clear?
Yes, it's clear.
Clear. Okay. Now move on to the next one. Here the question is different. Before finding the answer, read the question carefully.
Ma'am, is there no conditions for this?
From the highlighted letters, you will get the condition if it is there. So some questions will be like this. Okay, using the given digits, you have to form 6-digit numbers. Using the given digits means you can use all the digits and nothing, no other conditions are given. So what is the meaning of that? Deepesh, can you explain how did you get your answer?
Okay, so since there are 6 digits, and since there is no condition, we can repeat it. So we can get the answer as 6 raised to the power 6.
Yes. That means here no other conditions given means repetition allowed. You can use all the 6 letters in each place. So in every place, 6 digits you can use, not letters, digits. So it will be 6 into 6 into 6 into 6 into 6. That is 6 to the power 6. That is 6 to the power 6 answer they calculated. Very good. Sangvi and Dipesh calculated that answer also. Okay, very good. Now, look at the next question. Using the same digits, but here the question is little different. Read the question carefully and answer it. Look at this one. This is 6 different places, but here the condition is all the given digits. So every time you have to use all the 6 digits. Means what? Repetition not allowed. You have to take all the 6 digits every time. So repetition not allowed. Hence, what is the answer? 6 into 5 into 4 into 3 into 2 into 1. That is 720. This way, if you write, instead of 1 into 2 into 3 into 4 into 5 into 6, we can say it is 6 factorial. It is 6 factorial. That is a notation. The students, those who are in 9th standard, 10th standard, 11th standard, they may not be knowing about that factorial notation. So factorial 6 means 1 into 2 into 3 into 4 into 5 into 6. Okay, so what is factorial 5? What is factorial 5?
1 into 2 into 3 into 4 into 5.
Yes, what is that? That is equal to 120. 120. So we have done now so many questions. All these questions are permutation questions. different ways we were arranging the numbers with a certain rules. Sometimes there are certain rules, sometimes the rules will be more conditions apply, sometimes repetition allowed, sometimes repetition not allowed. There are certain other rules also will come. Okay, so these are permutation questions. Okay, so you can see here using the digits 1, 2, 3, 4, 5, 7 and 8, how many different 8-digit numbers you can form with repetition and without repetition. Now you can say the answer in terms of factorial notation. What is the answer for without repetition? 8 digits without repetition. Yes. There are answers. Yes, correct answer. It is 8 factorial. It is 8 factorial. And if no repetition, it will be 8 to the power 8. So these all things you will see in your senior classes when you reach in 11th standard or 10th standard. Your teachers will teach you more about the permutation, okay, and combination. Now, to understand the ragas, different combinations in ragas, this permutation knowledge is enough. Okay, now you can see this is permutation you are going to do in your senior classes. 1 factorial, 2 factorial, 3 factorial is 1, 2, 3. 4 factorial is 24. Then 5 factorial, 6 factorial. This is the way you will get answer. You will get answer. Okay. So with this knowledge, we will create ragas tomorrow. Today we have a guest, that is Kevin John. He was my student. Okay, before Kevin start, I want to tell you he is a drummer, and he knows many different types of instruments. Okay, yesterday I was explaining to you about the string type instruments and their different frequencies. But when it comes in the form of drums, the rhythms are different. Rhythm, okay, rhythm, or in Indian or in Indian style we say tala, different types of tala. That rhythm, there is no frequency there. Instead of frequency, that time signature will be different for different tala. Okay, in one beat, how much time they are taking. In the same time, you can make 2 beats or 4 beats, etc. This is differentiating different tal. Now, Kevin is, and in Muscat, I think everyone knows Kevin very well. You can introduce.
Yeah, so hello everyone. My name is Kevin John, and I'm an associate of Trinity College London, or some people might have know about this as ATCL. So basically, ATCL is equivalent to the first year of a college degree. And by the grace of God, I have completed ATCL with distinction, and I happen to be one of the top scorers in the Sultanate of Oman. And apart from ATCL, I also have 2 8th grade certificates from Trinity College London. And I have been learning music since I was 3 years old. To be precise, I've been learning drum kit since 3 years old. And oh, sorry, by the way, a big thank you to Tessy ma'am for giving me this lovely introduction. And for those of you who don't know, Tessy ma'am used to be my teacher back in 11th standard and 12th standard. She used to teach me. She used to be my class teacher and my mathematics teacher. So a big thank you for Tessy ma'am for giving me the wonderful opportunity to speak and demonstrate a few things related to music in this session. I am well aware that I don't have much time in this session, so I just want to keep my part very short. And in this short period of time, I would like to speak on music beats. So basically, music beats is like an internal clock of music. It's like the backbone of music. You can compare music beats with the heartbeat, because in a heartbeat the pulse is always constant. Similarly, in music, the pulse of the music beats are always constant, and it is organized in certain sections, and these sections are separated by bar lines. And there are many ways to organize your music, but I don't want to get deep into that because it's going to take a lot of time to understand the concepts. But I'm sure that the people who have already studied music might have a clear understanding of all this. And now if you see the relationship between maths and music, there's a lot in common between maths and music, especially if you see with the music beats. The music beats are derived through maths. And if I'm not wrong, you can get these music beats with the help of trigonometry. That's what ma'am said yesterday. So these beats that musicians play are played in a very systematic manner with the help of counting. And I'm 100% sure that without mathematics, we cannot measure proper systematic music. And finally, these beats that we play have values. And these values are also acquired through maths. And these values have different rhythms, and this happens to be a final music. And I'm not sure if you all follow, but the bottom line is that math is the base for music, and not only in the case of music, let it be engineering and finance, problem solving, etc. Anything in this world, math is required. And before I go any further, I want to show that what I'm holding right now is an Arabic instrument called darbuka. Some people call it goblet drums, and you can find this instrument played in Middle Eastern countries. So just like how the people from Kerala play chenda and tagil, similarly people from the Middle Eastern countries usually play darbuka. So I'm just gonna demonstrate some of the basics of music beats through this instrument. Yeah, so firstly, let's start with semi-breve. So semi-breve is known as the whole note, and the value of the semi-breve is 4 beats. So this means that we count to 4 while holding the note. For example, it'll be like 1, 2, 3, 4, 1, 2, 3, 4. And the second note that we look at is minim, and we call it a half note. Main reason it's called a half note is because when the semi-breve is divided into 2 parts, each part is called a minim, and that's how the value of the minim is 2 counts. For example, it's going to sound like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So the second note I already told you it is minim, and then the third note is called the crotchet. So the crotchet is a quarter note. So the value of the crotchet is 1, and this means that in one semi-breve there is 4 crotchet. So it's going to sound like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And after crotchet, there's this note called quiver, or some people can call it the 8th note. So when we divide the crotchet, we get 2 quivers. And if the value of the crotchet is 1, then when we divide the crotchet into 2 parts, we get each part worth half count, and that is called quiver. And in one semi-breve, there is 8 quiver note, and that's how we got the name 8th note for quiver. And so while we play quiver, it's going to sound like this. And then there is semi-quiver. Semi-quiver is also known as the 16th note. So it is the half of the quiver. So it's going to sound like. And then finally, we have the demi-semi-quiver. It is also known as the 32nd note. It is the half of semi-quiver. So demi-semi-quiver is going to sound like. And apart from all these notes, there is other musical notes such as hemi, demi, semi-quiver, brave, and so on. Anyways, let's not much detail into the all that.
Okay. Thank you, Kevin.
Yeah. Thank you so much, ma'am, for giving me this opportunity, and thank you
Okay.
everyone for bearing with me.
I hope he remembers mathematics.
Yes, ma'am. I remember mathematics.